Vocabulary of the day, zeros of a function. We talked about this with linear functions. Today we're going to talk about it in terms of quadratic functions. Zeros of a function is defined as the x-intercepts of a function's graph, or the value of x when x is equal to y. We're in 8.5 on page 525 through page 531. Previously, we factored out the greatest common monomial factor. Now we're going to factor trinomials that are in the form ax squared plus bx plus c. We're going to take a trinomial and we're going to essentially unfoil it. We're going to turn it into two binomials. To do so, we have to focus first on the number and list the factor pairs. So what are the factor pairs of positive 2? And with this middle term being positive, we only have to list the positive ones. So integers, watching your signs is very important in this. And in this case, 2 only has 2 factors that give us a sum of 3. I'm going to do the sum in a red color off to the side so you can start to see the process we're looking at. So this would factor into x plus 1 times x plus 2. If we were to FOIL this, we would end up with this trinomial. Remember, the commutative property says order doesn't matter, so you could also have it listed in this format. Focusing on our second example, again, these are on the bottom of page 525. We want to look at the number 10 and try and come up with positive only factor pairs of 10. Positive factor pairs of 10 are 1 times 10 and 2 times 5. Off to the side, we're going to look at sums. This would give us 11, and this would give us 7. Remember, sum is adding. 2 and 5 is 7, 1 and 10 is 11. Our middle term is 7, so it appears as though this is the factor pair we're looking for. So our answer would be a plus 2 times a plus 5. Again, all positive here. Factor pairs of 14 that are going to give us a positive 9 is our goal. We have 1 times 14, 2 times 7. Off to the side, let's find our sums. We would have 15 and 9. So it looks as though this is the factor pair we want to use. We would factor it as t plus 2 times t plus 7. Here we get into both positive and negative. Again, those integers I've talked about all year long. They go along with example 2 and 3 in your book on page 526. So in this case, we have a positive 3. What are the factor pairs of positive 3 that give us a negative 4? Well, if this is positive, but we're looking for a negative, that means we're only going to list the negative factor pair. So negative 1 times negative 3. And off to the side, I can see that that does equal negative 4. So that's what's going to work. So it would be x minus 1 times x minus 3. In this example, we have a positive 12, but our middle term is negative. So again, that tells us we need to focus on the negative factor pairs of 12. Negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. If we look at our sums, this would be negative 13, negative 8, and negative 7. We are looking for this factor pair because we're looking for the negative 8. So it would be t minus 2 times t minus 6. Here we have a negative 20. If this number is negative, that means our factor pairs are one has to be positive and one has to be negative. For example, positive 1, negative 20. Negative 1, positive 20. Negative 4, positive 5. Negative 5, positive 4. Negative 2, positive 10. Negative 10, positive 2. We are looking for, if you recall, there's an assumed 1 there. So we're looking for the sum of positive 1. Well, this would be negative 19. This would be positive 19. This would be positive 1, negative 1, 8, and negative 8. We're looking for the positive 1, so it appears to be this factor pair. So it would be m minus 4 times m plus 5. Here we have a negative 16. So again, we're listing positive and negatives here. So negative 1 times 16, negative 16 times 1, negative 4 times 4, negative 2 times 8, and negative 8 times 2. Looking at our sums, this would give us 15, negative 15, 0, 6, and negative 6. We are looking for a positive 6. It appears to be this factor pair. So we would have W minus 2 times W plus 8. And guided practice for example 4 in your book on page 527. This one, the directions say to solve. So to solve, I've got to get my 24 to the other side. It appears I subtract it from both sides. So we would have s squared minus 2s minus 24 equals 0. So we're looking for the negative factor pair, the factor pairs of negative 24. One would be positive, one would be negative. So negative 1 and 24. Negative 24 and 1. Negative 2 and 12. Negative 12 and 2. Negative 4 and 6. Negative 6 and 4. And I don't think we're done yet. We still have negative 3 and 8. Negative 8 and 3. So if we start to list our sums over here, we would have 23, negative 23, 10, negative 10, 2, negative 2, 5, and negative 5. We are looking for negative 2. So it appears as though this is the factor pair we want. So it would be s minus 6 times s plus 4. That would give us our middle term of 2. There's an excellent table in your book that helps explain whether you would be looking for positive and negatives. I highly suggest you use this as you're working your way through today's assignment.